can start. I will share the presentation again.
Thank you.
Gentlemen. Okay, last point we stopped at, it was after you shut in the well. So there is difference between the hydrostatic column for the fluid and the gas. So the gas, according to the difference in density, start to migrate up to the top for the well. So after you shut in the well, you will have, this is flowing, tubing head pressure, well flowing. After that, you start to shut in. So you'll start to reach shut-in pressure at the surface. So the gas start bubbling to raising up to the top for the strength. So it will be gas, then oil, then water, or oil below. So here the bottom hole pressure start to building up, then stabilize it. It will be equal, bottom hole pressure, it will be equal formation pressure, equal to hydrostatic head for the oil, plus hydrostatic head for the gas, plus the shut-in tubing head pressure. This is there is here build up due to effect for the gas cap or gas migration, then the stabilization happen. This is the immediate here, gas and oil separation. So you will find increasing and build up because of the gas migration. After that, the well, it will be stabilized. Okay. So we'll start here from flow tubing head pressure, shut in here, then build up, gas separation from the oil, then it will be stabilized. In this area, so we have fluctuation in building up for the reservoir pressure till it is stabilized. So the formation pressure, it will be the column and hydrostatic head inside the string plus shut-in tubing head pressure. Okay. So when do we need to kill? Yeah.
Ahmed, please, can you please explain where this pressure is going to be measured? At the top of the well? Yes, right?
This shut-in tubing head pressure at the gauge on the Christmas tree valves, on the top for Christmas tree on the tubing side, because the annulus is separated by pucker from the top above the formation. So this one will be inside the drill, the string or tubing or production pipe.
Okay, fine. So the first graph where the BHP is at the left side, and in the second graph, the FTHP, flowing tubing head pressure. So for first graph is for the leftmost picture, or what?
Here
what these graphs
from left, here the well is flowing. Okay.
Okay.
So at the flowing, the gas is coming and the oil up to surface. So what you read at the surface, flowing tubing head pressure according to the choking at the surface for the production.
Okay.
After that, I will start to shut in the well. I will shut in the flowing. So the flowing start to stop and start the surface gauge at the tubing start to build up because you stop flowing. So there is build up at the surface. Here, this is the initial build up. At the initial build up, the gas bubble will start to migrate because the difference between the density of the oil and the gas. So the gas, it will be on the top. This is the gas cap effect. It will be raising on the top for the tubing, and the oil, it will be in the bottom or below. If you have water, it will be in the bottom for the string. So after that, you will start to stabilize it for the well. This shut-in tubing head pressure, it will be plus the hydrostatic head for the column inside the string. It will be equal formation pressure, equal bottom hole pressure. This is the well now is stabilized. Okay.
Okay, fine. Thank you.
Okay. You're welcome. Why we need to kill the well during completion or during well intervention? Apart from planned well kills, there is some emergency or major or minor leaks can develop. So we need to kill the well. Like what? Like main sealing failure, ring gasket or elastomer or valve, so we need to pump kill fluid inside the well to stop flowing, or failure to seal around the wire or unable to cut the wire. So you have option to kill the well before you cut the pipe or the wire line. Well intervention tools is stuck across the POP. One option is to kill from the Christmas tree. Failure or rupture or flow line at the surface flow line is damaged, so you can pump kill fluid from the Christmas tree if available. Failure of riser or lubricator. Failure of hydraulic control line to surface control subsurface safety valve, so you can pump kill fluid inside the well, opening the subsurface safety valve. Failure in the tubing of your, or if you have leak in the tubing, so you need to stop flowing, you need to kill the well first, then you pull out to chain the pipe. Failure of pucker or seal assembly to seal annulus from the tubing. This is some situation can happen, so it is lead to start kill the well with prime. What is the well information data required for the killing operation? If I need to kill the well now, so what is the data I need to collect before I planning to calculate the kill fluid density or kill mud fluid? What is the data I need? I need to know the fluid type in the tubing and annulus, what contains, wellhead pressure and the pressure rating to select the suitable rated working pressure for the pump, formation type and the pressure, stabilized formation pressure at the bottom to calculate the balanced kill fluid, formation fracture pressure to not exceed during killing operation, casing and the tubing size to calculate the volume for the tubing and the annulus, casing and the tubing strength, the collapse and burst value resistance to not exceed this collapse or burst to not make broken or pipe or leaks inside the casing or pipe. This is the data you need. You need to know where the perforation depths, pucker depths, and from where you start to circulate the circulation port, like SSD depths, sliding side sleeve, opening by shifting tool by slip line. And what is the maximum allowable surface pressure? What is the maximum safe pressure I need to work at the surface, not exceed to not make problems during killing operation, which is called MASB, maximum allowable surface pressure, usually 80% as safety factor from the maximum pressure planned in the well program to kill the well, to be in safe side. What is the maximum allowable surface pressure? It is the maximum surface pressure, tubing or casing side, during the operation. Factors can affect the maximum allowable surface pressure like what? Like first, tubing burst and collapse rating, casing burst and collapse from outside and burst from inside, you know that, and wellhead and Christmas tree surface equipment pressure rating to not exceed, formation fracture pressure, the return manifold at the surface, the choking at the surface, it also factor effect on the mass for the killing operation. What is the preparation we need to kill the well? Here we talk about regless operation. So first we need to shut in or close the well first to make a stabilization, so we can read the shut in wellhead pressure or shut in tubing wellhead pressure, and this pressure at the surface will convert to fluid weight, adding to the hydrostatic head or the column or the mud or the fluid weight inside the string, so it gives you the balance at the bottom for the well to kill the well without any overbalance. Second thing, if you are going to run any slip line deployment pressure gauge to get accurate data about the bottom hole pressure or the formation pressure, we need to check and inspect and pressure test Christmas tree and wellhead valves to make sure it is holding the pressure and there is no leaks, especially if you're working with gas well or high percentage for H2S. check if subsurface safety valve need to be lock open in case of tubing retrievable safety valve, or it is bolt if it is wire line retrievable safety valve. We need to run slick line to retrieve to make pass for the pumping kill fluid. Perform drift run to locate if you have doubt for any restriction inside tubing and which depths. Isolate the well from production control system and emergency shutdown system if necessary, and ensure all pump well intervention equipment and organize it, including pumping equipment and its capacity and the volume to kill the well. Usually when prepared to kill the well, the volume for well, we usually mixing 1.5 to 2 times volume for the hole for safety. 2 times the volume you need to kill the well, it will be prepared from the beginning on the surface. This is the pump.
Mr. Ahmed,
Yes.
question. The first point is well must be closed in to stabilize shut-in wellhead pressure. If we don't have any, if we have a leakage on wellhead, then do we close the well from the downhole, like from triple SV?
Yes, you can close from subsurface safety valve or close from the lower valve on the Christmas tree, but you need to replace the top valve. After you set the plug inside the well bore, so you have 2 barrier, then you check its integrity, then you replace the top valve, like crown valve or wing valve.
Okay, what it means like we can close from the lower master valve if we have a leakage in killing valve or like flowing valve, then we close the valve from the from lower master valve and then try to stabilize the wellhead pressure and then open it to kill the well.
Yeah, sure. Yeah, if you have valve leaking, the lower master valve, in this case, you need to set one plug like back pressure valve or tubing plug inside the tubing at shallow depths, plus you close the subsurface valve. So you have now two barriers. So you can replace the Christmas tree valves above.
Okay, we have 2 barriers in this case. Like we have a triple SV and the 2H check valve or the BPV we have installed in Christmas tree. So in this case, do we need to kill the well, or these 2 barriers would be enough?
No, this 2 barrier it would be enough, because the main plan for well intervention operation like coiled tubing is not to kill the well. This is the main advantage. You're working with flowing well or well under pressure.
Okay.
This is the main advantage for well intervention operation.
Okay. Mr.
Okay. Here we talk about pump equipment. It will include pump. Usually this pump, twin pump, 2 pump. One is backup. Surface line, choke manifold for return, have a choking, isolation valves, pressure gauges, accurate and calibrated, fluid disposal system to where you will take the fluid back from the well, to tankers or to flare pits or to production line, mixing tank to mix with agitator the brine, and reserve tank to store excess storage for volume for water, fluid, this is water, and chemicals, which is viscofire and also salt to kill the well and to prepare the kill fluid.
Ahmed, what are the isolation valves?
Isolation valve, this is the valves between tanks and isolation valve. This is a manual valve to close and open to separate one valve, one tank from another. Yeah, this is called isolation valve.
Okay, fine, thank you.
Okay. Okay, so what is the well killing method during workover or during well intervention operation or completion phase? Usually, we have 4 ways to kill the well. First way, can we make mute, please?
Mute.
First method is called bullheading method. Second method is called forward circulation. you pump from a string, take return from the annulus side. Third way is called reverse circulation. You pump from annulus side, get return through the string. And number 4 is called lubricate and bleed. This is last option or unconventional method for killing the well. Bullheading, that means you start to inject back all the string volume containing oil and gas and replace it with kill fluid back to the formation. So that's why this method is called most preferred method in case of emergency. You just pump kill the volume for string for the pipe to have 0 at wellhead pressure with easy and fast way. So that's why it's called, usually in the exam, which when you ask you about emergency killing operation, usually it is bullheading, small volume, pump it back the shit or the oil without taking at the surface, without circulation. So you are able to kill the string. This is the bullhead method. Forward circulation and reverse circulation and lubricate and bleed. Usually we call reverse circulation is the best planned kill method. In the exam, usually the selection for best planned kill method is the reverse circulation. Why? Because we just start to pump kill fluid from the annulus, and the annulus usually above the pucker contain completion brine is equal to the formation pressure. So when the completion brine just enter the capacity for the string, you killed already the string, the well from the string side. So all the gas and oil is coming out from the tubing without contamination.
Like we do in the DST.
Yes, yes.
Rupture the RD and then for reverse do this reverse circulation.
Yes. So you just take capacity for the string to be able to kill the well, and you need to continue to have homogeneous fluid inside the well bore and annulus and the string. That's why it's called best planned kill operation. So usually the first option I need to go with, it will be the reverse circulation. If I am able to circulation the hole. The second, if I don't able to circulate, so the second option will be bullheading. I will bullhead in case of I cannot circulate all the hole with the kill fluid. If for any reason, if I cannot bullheading, like the perforation is plugging, there is plug inside the drill string, so I will go to use last option or alternative method, which is called lubricate and bleed. This is under extreme cases only. We will talk about 4 methods in some details. Let's check first method here, which is called bullheading. Bullheading method, that means, this is a bullheading. That means you have pump at the surface. Here there is pucker and completion brine above the pucker, and this perforation. So your SSD is closed while running in hole, while completion or production phase. So I will start to inject fluid, killing fluid inside the string here or completion string, pack or squeeze all the oil and the gas back to the formation. So I replace the oil and the gas inside the string with kill fluid. Finally, I will read at the string here 0 after I kill or pump kill fluid or completion brine. So the definition here, pump kill fluid through tubing, squeeze it back to the formation, use in case of emergency or if you have high toxic percentage for H2S or CO. So it will be more risky if I circulated out this percentage for gas to the surface. So in this case, you will bullhead. When I can use bullhead? Yeah.
Ahmed, we perform bullheading through the kill line of a Christmas tree, right?
Yeah, from the wing valve or kill line valve in the Christmas tree.
Okay, fine. And we are not taking any returns from the.
No. We just close all valves and all the fluid squeeze it inside the well, the formation.
Okay, thank you.
Okay. So when I start to use bullheading, first one in case emergency, you have leak in Christmas tree. So the first option here is to pump some kill fluid inside the string to have zero at the surface. If you cannot open SSD or punch pipe for circulation, for any reason, SSD is stuck in closed position, you cannot open or you cannot circulate, so you will go to use the bullheading method. But if you need to use bullheading method, you must be able to make injectivity test to check the perforation is open and it can take fluid inside. Okay. What is the advantage for this method? Quick and easy method, especially for smaller tubing size, like 40 barrel capacity for the pipe. So 40 barrel you pump it, or 50, you will have zero at the wellhead pressure. That's another advantage or second advantage. No hydrocarbon oil or gas is brought to the surface. All is squeezed back to the formation.
Mr. Ahmed.
Yes.
Must apply injectivity test. Can you repeat this point and explain it again?
What the mean for injectivity test? I need to check this fluid at this formation at different rate for pumping. It can take fluid inside. It's not blood.
Yeah.
So I start, for example, with 1 barrel per minute with pump. So I record the pressure and volume I pump it inside the perforation. Okay. After that, I will increase the pump rate to 2 barrel. And I check the pressure and how many barrel I inject inside the formation. This is called injectivity test.
Okay, fine. Thank
you. Yeah, Mr. Ahmed, I know the rules for injectivity tables, but if the formation is not getting in any intake, like the injectivity of the formation is very bad,
yeah,
then what we should do?
You will not be able to bullhead. You will
circulate. We wouldn't. Yeah.
You will use your open SSD to reverse circulation the well.
Okay. So, but if we do not, we can't be able to open the SSD or punch pipe for circulation, then what would be the case?
It will be lubricate and bleed. Last option.
Okay. Okay.
Okay.
Thank you.
Disadvantage here, scale in the tubing in the wall for the pipe here from internal diameter, maybe pump it back to the formation. It can with time cause plugging to the perforation. Disadvantage also, fracture pressure for the formation. We don't need the surface pressure plus hydrostatic for the fluid to exceed the fracture pressure, to not cause losses to the fluid and inside the formation. Formation permeability here, the same what we said from 1 minute. If you have low permeable zone, that will mean is tight formation, low permeability, it will not take any fluid. So this is disadvantage. If you have formation permeability is factor for the bullheading. Tubing burst pressure and condition. What is the condition for your pipe? And you not need to exceed the burst value. If you exceed while bullheading, you will have crack or leak inside from the pipe. Last disadvantage, gas. If you have gas light fluid, may slip up the tubing if the pump rate is not sufficient for large tubing size. If you have large tubing size and the pump rate does not exceed the speed for the gas going up, after you shut down the pump, the gas is still slip up through the tubing to the surface. In this case, if you have especially H2S gas, we recommend in this case to add some viscofire, some viscous to the brine to make it viscous brine. The viscous brine, it's helped to not give chance for the gas to migrate or slip up through the brine. Okay. And usually we recommend to bullhead 1.5 volume capacity for the string to eliminate any contamination at the bottom for the string. This is for bullheading operation. Okay, gentlemen, clear?
Yes, Mr. Ahmed, it's clear.
Okay. Moving to circulation method, we'll start first with forward circulation. In forward circulation, as we said here in the well, you'll start to pump in from the tubing. First, you run with a slick line, as we said, to put wire line plug at the bottom for the string above the perforation. After that, you run another wire line to open the SSD, check it is open. Then you start to pump kill fluid inside the string, take the return from the port for SSD back to the annulus valve at the wellhead. So you pump forward from the string till all kill fluid is reached to the surface. So pump kill fluid through tubing, return from the casing side. The advantage here, little or no damage to the formation by foreign fluid or contamination from tubing or annulus, because you install already wire line plug. So here you isolate your completion brine from the formation. So less risk for formation damage if your brine or kill fluid is not compatible with the formation. What is the primary barrier here during killing operation? Where the primary barrier?
It would be Christmas tree?
No, it will be the wire line plug here.
Oh, okay, yeah.
It is our primary barrier. So in our case here, the kill fluid is not primary barrier. It is dependent on the operation. Not usually the kill fluid is primary barrier. In this case, the primary barrier here, wire line plug, and the secondary barrier will be the hydrostatic head for kill fluid. After you remove the wire line plug, your hydrostatic head for the kill fluid will be the primary barrier. So in some cases, the kill fluid cannot be the primary barrier, like here. Okay. The disadvantage, you need to pump large.
Mr. Ahmed, in this case, primary barrier would be the wire line plug, and the secondary barrier would be the kill fluid.
Will be the hydrostatic head for the fluid.
Yeah, okay. The kill fluid would be the secondary barrier.
Yeah.
Okay,
till you recover by a slick line the wire line plug after you finish. So the primary barrier will be the hydrostatic head for the fluid against the formation.
Okay, Mr. Ahmed, thank you.
Okay. Disadvantage, you need to pump large volume. You pump tubing volume plus casing or annulus volume. Influx here will be beneath completion and kill fluid. The oil is not coming out because the oil usually below the SSD. So you just pump kill fluid, but the oil here is still below. Contamination can be happen after you shut down the pump between the difference in density between oil and the gas below and kill fluid. In some cases, the oil and the gas start to segregate or migrate due to its density through the kill fluid. This is also one of disadvantage for circulation method.
Ahmed?
Yes.
In the bullheading case, we will not have the wire line plug, right?
Yeah, you don't have, sure, because you need to pull it. Formation should be open.
Yeah. So in the bullheading case, what will be the primary barrier? I guess the primary barrier will be the fluid, and there will be no secondary barrier, or might be the pumping unit will be the secondary barrier.
No, the primary barrier will be the kill fluid. Plus, if you have any flow, you will shut in the Christmas tree valves at the surface. It will be a secondary barrier.
Sorry, I didn't get you.
Christmas tree valves will be secondary barrier at the surface to shut in the well from.
Okay, but we will be pumping from it.
We pump it. Yeah, we pump it from Christmas tree. So during pumping, you're killing the well now. So the kill fluid, you pump it, it will be the primary barrier. After you pump, you will check the pressure at the surface. If it is zero, okay, the kill fluid is the primary. and any valve from the Christmas tree, it will be secondary. But if you
Okay,
have built up at the surface, so you need to recalculate again your kill fluid density. In this case,
Okay.
you will shut in the well with Christmas tree valve to prepare kill mud weight again. In this case,
fine.
the valves for Christmas tree will be the primary.
Okay, fine. But when we will be pumping, then what will be the secondary barrier?
No, we don't have secondary barrier. Secondary barrier,
Okay.
this is during well intervention operation under pressure to hold the pressure of the well. But in this case, we start to pump and kill fluid. So we just start to kill the well. After you kill the well, you check our barriers.
Okay, fine, got it.
Okay. Last disadvantage.
Mr. Ahmed,
Yeah,
triple SV would be our secondary barrier as well.
Which one?
Triple SV.
What the? I don't.
Downhole safety valve, DHSV,
okay.
would be our secondary barrier or it would be our tertiary barrier.
Usually, as we said before, according to the API, the downhole safety valve, it is emergency barrier for production only. If you need to use, in this case, it can be, but most of company policy is not rely on downhole safety valve.
Okay.
But
thank you,
if you have problem at surface Christmas tree and the string is filled with oil, so for sure you will shut in with downhole safety valve in case you don't have any tool inside the well pool. Okay.
Yeah, Mr. Ahmed. Okay, got it.
All right. The disadvantage here, last disadvantage, high surface pressure. You pump from tubing, a small area, and you get return from the large area, from annulus. So mainly you have high surface pressure in this method forward circulation. Let's check the reverse circulation. So the same, you start to pump from annulus, from the valve on the tubing spool, get the return after you install the wireline bridge plug or wireline plug, and you open the SSD, get return from the string. Okay. In this case, the completion brine already filled the annulus area from beginning. So, and when the completion string enter the capacity for the pipe, you will kill the well already, but you need to continue. So, or the fluid, kill fluid, is replaced the original and the gas inside the string and the original completion brine inside the annulus. So if you pump small volume like tubing volume only, you already killed the fluid. Even the kill fluid does not enter the string. In this case, also the advantage is low surface pressure, low pump pressure. You pump from large area, you take return through the string. Influx here in this case will not enter the annulus. The gas and oil after you pump capacity for pipe will be out from the tubing. But in the forward, the gas, if you have contamination, the gas and oil will enter the annulus. It will go through large volume or greater area volume to get to the surface. But here you get the gas and oil quickly at the surface without any contamination. This method also helps to clean sand in some cases from the wall of the pipe. Why? Because the jetting effect. The fluid will go through a small port SSD, so its velocity will be maximum pressure drop here. So it will help to jet the pipe from inside to clean some sand on the wall for the pipe with high velocity. The disadvantage, this method is slower than the bullheading because circulation method. Last method is the lubricate and bleed. So first we choose circulation method, it will reverse circulation test plant. And if you don't have option for circulation, I will go for bullheading. if I don't have plan or I have problem with bullheading, I go the last option, alternative method, lubricate and bleed. So this method is not non-conventional method, is used in special condition. Here in this case, the SSD is closed, stuck in closed position, and we don't have able to circulate or bullhead. So I need to replace the oil and the gas inside the string with kill fluid. We have calculation for this method, lubricate and bleed. So I will start to build up pressure at the surface. According to working pressure, I will calculate some volume related to pump inside the closed system, inside the string. Then I wait the time for lubrication. That means the kill mud will start to coming down due to difference in density. Oil and the gas start to come to the top for the string. After that, I will open the well through the choke and I bleed the same volume I pumped as oil and the gas from the hole. This method is especially, we can perform especially in gas well. Pump a small amount of kill fluid, then I will wait lubrication time like 15 minutes. Then I will start to bleed small amount of gas or mixture for gas and oil. In same way, I keep while bleeding off bottom hole pressure constant. This is the scope for killing operation. You need to get the influx or oil and the gas out while pumping kill fluid without getting additional gas from the hole. So you all the time, I keep the bottom hole pressure above the or equal to the formation pressure to not take secondary or additional gas or oil from the formation. After we repeat this sequence many times, and it's take long time and need also competent crew and experience, and there is calculation, but the calculation is not in this course, is not a scope for this course. So after that, I will replace all the gas from the tubing by kill fluid. So I will reach to zero at the well head. Alternative method of bullheading. The main advantage, only method can be employed under extreme circumstances like no bullheading, no circulation. The disadvantage here, very, very slow. It can take 2 or 3 days like this to replace the kill fluid inside the string. Required high surface pressure compared with circulation method.
Mr. Ahmed, I have a question regarding bleed and lubricate method. Suppose if we have a case in which we have around 200 psi, or if we have a shut-in pressure of around 2 to 3,000 psi, and we are trying to kill the well with this bleed and lubricate method, then as first we will make a pressure in the line which would be above 2 to 3,000 psi, and then open the well to pump the kill fluid inside well. As we would be starting pumping of kill fluid, the pressure would be we would be getting a pressure more at pump.
Yeah,
you're getting my point. Okay, so some of the volume would be pumped, and since there would be, if we have any compressible fluid inside well, then the kill fluid would be pumped, and then we will shut the well and try to segregate give some time to segregate the kill fluid and the gas compressible fluid to come up, and then we will bleed the gas from well and again pump some of the kill fluid again. That's how we will proceed with lubricant.
Yeah,
okay.
but here you don't open the well while pumping kill fluid. The well is closed.
Okay, I got that point. But at the stage of bleeding the well, we would be opening the well to get the gas out of the well and again start pumping.
Yeah, when you bleed the gas, you cannot control or measure the gas volume. So we work in the pressure increasing at the surface to bleed amount for gas the same equal to the volume you pumped inside the well plus the compressibility due to the effect of the bullheading in closed well, some volume. So you bleed this volume.
How much pressure we would bleed?
How much pressure?
We will bleed.
Usually, when the pressure at the surface is stabilized, I will choose something called safety margin. Safety margin, I will make the pressure increasing in gas well due to gas migration by 100 psi. Now I have in bottom hole pressure 100 psi over balance. Okay. Then I will then I let the pressure at the surface increase more, like 50 or 100 psi more. This will call working pressure. I will take this 100 psi and convert to height at the surface inside the pipe, and I convert to volume. Okay.
So
then
if we have a non-compressible fluid like or slightly compressible fluid like oil in well, then that would be difficult for us to pump inside well.
It will be. It will be. Yeah. It will be.
If we don't have any injectivity from if intake from the reservoir, then that would be difficult for us to compress the slightly compressible fluid inside well.
It will be a little bit difficult. That's why I said this method is especially. It will be more easy with gas well, pure gas well. But we can use in oil and gas well also. You will let the pressure increase, working pressure by 100 psi. I will convert 100 psi to pressure. Then I will go to pump this volume inside the well. This volume actually can be 1 or 2 parallel. Okay. When I pump 1 or 2 parallel inside the string, the choke is closed. So now I will let the pressure increasing again by 100 psi. At that moment, I will open. After lubrication time, waiting time, I will start to open to bleed only gas or oil and gas. If I bleed kill fluid, I will close again and waiting some time. So after that, I will open, drop the pressure 100 psi at the surface, equivalent to the volume I pump it inside the well or the tubing.
Okay, I got that point. I got it. Thank you so much, Mr. Ahmed. I got your point. Like you the lubricate method. When you shut in the well, you would be giving time for the kill fluid to segregate as a density difference inside well. That the oil would come up and the kill fluid would go down. And in this way, you would fill the well with kill fluid, whose hydrostatic pressure would be more than the formation pressure.
Yes. After each step, I repeat this one in maybe 10, 11, 12 step. According to the volume, you pump it and the capacity for the string. I will end with this method, gas all out and kill mud inside the string. So zero at wellhead.
Okay. Thank you so much, Mr. Ahmed. Thank you so much. I got your point.
Okay. Ahmed, I have a question. So we will be performing this operation with CT or through
no, tubing. With tubing. You pump from kill line of the Christmas tree.
Okay, fine.
The annulus is isolated zero wellhead pressure in the annulus because the SSD is closed and here is completion prime from the beginning above the pucker. So all here I play inside the string to replace the gas out and put kill fluid inside.
Okay, fine.
Okay. Mr. Ahmed, that would be more difficult if we don't have any injectivity from the reservoir as well.
Actually, I don't inject anything inside the formation. I just
but that would be more difficult.
Yeah. I just compress the fluid inside the string to have build up at the surface and wait some time to bleed gas.
Okay. But what I was saying that would be difficult if we don't have any injectivity as well and we have a well already filled with some fluid. So that would be difficult to pump inside well.
It will be difficult. It's not about injectivity. It will be difficult little bit with water well or gas well pure because compressibility for the prime and the segregation. You imagine the difference in density between gas 2 ppg and kill fluid and the difference between oil 7 or 8 ppg and the kill fluid. It gives you difference here, so it will be more easy for lubrication happen between gas and kill fluid instead of oil and kill fluid.
Okay, okay, Mr. Ahmed. Thank you. Thank you.
Okay, you're welcome.
Ahmed, can we perform bleed and lubricate method through coil tubing or not?
Through coiled tubing? No, through coiled tubing it will be circulation. You will, if you're not able to bullhead the drill string, for example, okay? So what you will do, you will rigging up coiled tubing, run inside the string to the bottom, okay, and you start to displace the capacity for the tubing with kill fluid. Or you can milling, make clean out for any restriction inside the tubing, get the restriction free. Then you displace the brine inside the tubing with coiled tubing. So you kill the well with coiled tubing, with circulation.
Okay, fine.
Okay.
Thank you.
Mr. Ahmed, where we are going to use the forward circulation method, like if we have any stance to circulate the well, then why do we use apart from intervention? Like if we are running a coil tubing, then we the only method we can follow is the forward circulation. Okay, fine. But if we are killing the well with the completion, like the tubing, and we have the authority or to circulate the well, like we have an open SSD, then whether we should use reverse circulation or forward circulation. Reverse circulation is the better option, but when we would use the forward circulation method.
Actually, it's up to you. If you need to go with forward circulation, is your choose. We don't. Pause is ended with kill fluid, fill the string and annulus. But in forward circulation, you have too much contamination, oil and water inside the annulus area. Okay, and the same time, the reverse circulation, it gives you lower pressure at the surface, and you can, while pumping, all the gas and the oil is coming first out from the hole, so you can control the well more easily than the forward circulation.
Okay. So there is any specific advantage with forward circulation method to use it? Since we can do the reverse circulation method, reverse circulation, it is more feasible. So any specific advantage over reverse circulation in forward circulation or not?
If you don't have plug in the hole, wireline plug, the reverse circulation, it gives you pressure at the bottom for the hole higher than the forward circulation. Why? Let's look here. This is the reverse circulation, right? You pump from here, you get return from a string.
Okay.
While the fluid coming up, there is friction inside the string, right? The friction usually in the opposite direction for the flow. So there is friction inside the string and through the SSD will make back pressure or more pressure on the formation if you don't have the wireline plug separation. So that means the ACD in the bottom for the well, it will be high. If the friction pressure acting plus the hydrostatic pressure during the reverse circulation exceed the fracture pressure, we will have losses, especially in low fracture formation. That's why in this method I will use this method forward. Why? In forward, the only pressure effect on the bottom is the APL, annulus pressure loss. While the fluid coming up, there is friction will affect down on the bottom for the hole. This pressure is less than the small or highest friction inside the string itself and SSD.
So it means that the formations with low fracture pressures, we should use forward circulation method.
Yes.
Okay. Thank you so much.
Thanks. But if you install wireline plug in post, the bottom hole pressure or the formation will be isolated, so we can go with reverse.
I got it.
Okay. How to can calculate the kill fluid? Here, kill fluid weight, you have another equation in formula sheet. It will be equal current fluid in the string plus shut-in tubing pressure, I will convert to weight divided by 0.052 by perforation TVD. It gives you how much ppg for the kill fluid equal to the formation pressure. Usually in the exam, the kill fluid or weight rounded up or 1 decimal after point mark. I mean, if the kill fluid is 13.322 in calculator, it will be rounded up for safety or to be overbalance the formation to 13.4. If it is 10.02, it will be rounded up to 10.1 ppg. If it is 11.92, it will be 1 up, it will be 12 ppg. This is how to rounding up the kill fluid. Okay.
Okay.
After that, we'll talk about the gas hydrates. What is the gas hydrate? What do you know about gas hydrate?
It's something like the formation of solids due to the pressure difference.
Okay. In which condition gas hydrate can form?
Like if we have a choke, a pressure drop across which we there's a point across which we have a high pressure drop. Then the side at which we had the lower pressure side would have the gas hydrates.
Okay, gas hydrates usually it is convert of the gas under some condition. It's convert to ice mucus, ice plugs. It is plug the circulation path. The problem for gas hydrate is stop make complication while killing operation, stop the circulation path. So this is the problem, give trapped pressure upstream, the gas hydrate. The gas hydrate only can form under 4 conditions together. First one, relative high pressure, relative low temperature, in presence of water or vapor for water, especially low salt water or fresh water, and also in presence of hydrocarbon gas. If you break one condition, the gas hydrate will not form in the system. Usually during killing operation, we cannot control the 4 conditions. You have high pressure, if you have temperature or low, and vapor for water plus return contain gas, so you will form the hydrates through the choke or downstream the choke, usually downstream, because there is variety in pressure and temperature downstream. So it will block the and build up pressure above and stop the killing operation. So how we can minimize the effect for the gas hydrate or prevention or make prevent to the formation of gas hydrate? You have option here. This is the method. If you are able to reduce pressure, this is during production, or raise temperature, heating, or flowing the oil in production phase. This is out of our control during killing or well control or well killing. So the third one is our option: inject chemical inhibitor, anti-freezing chemical like methanol and glycol. Chemical is coming in drums, so you can start to connect small pump with control line in upstream, the return from the well, and you start to, with pneumatic pump, start to pump small amount for methanol and glycol upstream the fluid or upstream the choke through the fluid coming from the well. This one is prevent to form the gas hydrate. Methanol CH3OH, glycol C2H3OH. I prefer usually to use glycol because glycol is less toxic while using during killing operation. And one of them we can use also depend on the availability on the location. In some cases, if you pump some salt or high salt water, it can break the water phase. That means increasing the salinity will reduce the gas hydrate formation. So methanol glycol, and in some cases inject salt water in the line. After that, we talk about some condition related to the operation. Here we'll talk about the importance for handover and safety meeting. Why we need to make handover during operation, and what is the importance for the safety meeting? What do you think?
Actually, Ahmed, the importance of the handover and the safety meeting is that we will, in the safety meeting, we all discuss about the risks and risks in the operation that we are going to perform. And we also, during the handover, we also told the other supervisor, the other engineer that the following operation is going on. So we need to take care about the specific like calculations, or that suppose we are doing the bleed and lubricate method. So we must tell to the other person we are handing over that the following is the pressure trend, and that in how much time we have to bleed and how much volume we have to pump. So and in the safety meetings we need to discuss all the risks involved in the operation. Like there is the possibility of the exceeding pressure, there is the possibility of hydrates, gas hydrates.
And also what is the emergency exit or plan also in case of any unexpected thing happen. And also you need to know what is the role for each crew member in location during the operation. This is also one part from the safety meeting will hand over. And usually the handover is performed to make sure that the current operation are understood and will be safely and effectively continue. Like the handover, the best way, it will be written handover, not verbal information or instruction. Must be written, discuss each point with another shift, and also in the same place. After that, if you accept the handover, anything after that, it will back on you. Like when you hand over well from the production people to well intervention crew, or the reverse. If you accept the handover, everything after that will be on your responsibility. That's why the handover must be reported, signed, and filling or documentation in the filing system at the work site for at least 6 months. Okay, to be a reference if you have audit or checking on the operation before. Okay.
Ahmed.
Yeah.
Ahmed, can you go to the slide number 54? I have a question there.
50?
54. Yeah, no, this one, 55.
Yeah.
Okay, kill weight mud is equals to current mud weight plus shut-in tubing pressure divided by 0.052 divided by perforation TVD. So can you explain this slide? In the examples, there is the only kill mud weight is given, and then the final answer is the given. So how this is calculated?
This one?
Yeah.
After you shut in the well, okay? After stabilization, you have fluid, you have average fluid inside the drill string, right? Wait for like water or oil, okay? And formation pressure at that moment, it will be equal hydrostatic head. Let write on whiteboard. Let me share whiteboard. Here, after you shut in the well, you can see whiteboard, right? Formation, you can see what I write now?
Yeah, I can see.
Formation pressure after shutting the well is equal to P pressure hydrostatic for fluid inside tubing, right? Plus shut-in tubing head pressure. Okay. This after you shut in the well, so the pipe contain at the surface shut in plus fluid here, oil or water or mixture have some weight for the fluids. Okay. I need now the formation is balanced at the bottom. So the formation pressure and the analysis isolated is equal to pressure hydrostatic in the tubing plus shut-in tubing head pressure. I need to convert this one to kill fluid weight for fluid equivalent to the formation pressure at the surface here. Okay, so what will I do? I will divide the two sides at 0.052 TVD at the bottom for the well. So here it gives you kill fluid density or weight, right? Equal, when I divided this one by 0.052 TVD for the formation or perforation, it gives you current fluid weight at the string, right? Plus this one, it will be shut in tubing head pressure divided by 0.052 TVD for perforation or formation. What I do here, after stabilization, I convert the stabilized wellhead pressure to fluid weight added to the weight inside the string to give you the balance or kill fluid density. Here is equal to the formation pressure without any overbalance. After that, I will add, for example, for safety 200 or 300 psi overbalance to get more overbalance kill fluid density. This is the equation, come from this equation first. Understand?
Okay, thank you, Ahmed.
Okay.
Okay, in the examples, can you go to the slide?
I will back to slide. Here in this slide, there is rules according to IWCF. When this calculated on calculator, I cannot write the final answer like 13.322. Only IWCF said you need one decimal after point mark. So this is kill fluid density. So I will round up the first number up one. So it will be 13.4. Here it will be 10.1, 11.1. So that means, 11 plus 1, that means 11 ppg.
9. Okay, thank you. Thank you very much.
You're welcome. After that, we'll move to talk about MOC system. What is the MOC?
Management of change.
Yeah. What is the meaning for management of a change when we apply this system?
Yeah, actually, we need to, if we want to do something, we need an approval from the head of our department, and then we, and then that head of department also needs approval from his boss as well.
Okay.
This is what our management of change. If we want to change something in, yeah.
If you have vital change in the plan or program, big change, so you need to get approval, paper approved, sent to the from office to the site. That means we approved, all personnel in the same page agree to do this change without taking any verbal instruction. This is the system MOC, or management of a change. A signed documentation applied when there is a vital change in program plan. The purpose for the management of a change to evaluate first the risk related to proposed change, so that the unplanned consequences don't occur, to ensure that the change not bypass the current control risk. There is risk assessment you do for any job. If you need to have management of a change or change in plan, so you need to re-assessment again or recheck the risk assessment according to the plan. The main purpose for the risk assessment is to identify all potential risks, their likelihood, and which controls are in place to prevent them. This is the, so you have team for management of a change in office, and finally is assigned or signed with authorized manager. This is the sequence here. If you put plan for a change, implement the change, sustaining the change, assess for a change from beginning, prepare for the change. This is the cycle for success if you have vital change from program or the plan sent before to the from the office. Joint operational manual. What is the joint operational manual? This is something related to the operation, and some questions the exam coming related to this one. This is manual agreement or contract agreement between the client and third party. So we have manual or program signed from both parts. So it will combine operator and contractor procedure. And this is the manual you can go through during the operation. And if you have any change from that one, so we need to get new agreement to be available on site all the time for immediate reference. And in case of emergency, like the manual, agreed manual between contractor and operator or the client. Personnel charge, the equipment operator is charged to shut in the well when the pressure control program are raised during well intervention operation. In this manual, they mentioned who is responsible to shut in the well in case of emergency or well control. Only one crew member assigned to do this job. This person is, it will be mentioned in the manual or plan or the program for the operation. Another person can be also shut in case of emergency, one backup in case of the usually equipment operator or the operator who is responsible for shut in the well in case of emergency during coiled tubing operation. And this only the person can go to operate the POB. Okay, gentlemen. Any question to this point? Okay, to this point, we finished the first day for completion operation. I supposed to take 10-minute or 15-minute break now. Then after we come back, we'll choose some questions and calculation to solve together during the class. Okay?
Okay, Mr. Ahmad. Okay, thank you so much.
Thank you very much.